So when we're doing statistics, there's the actual collecting of data aspect and, displaying it, making pictures. But then there's the analyzing those pictures and the data as they're displayed once you've got those representations set. So we're going to now turn to describing the distribution of a quantitative data set. One of the first things you're going to want to talk about is the shape of the data. So by turning them into histograms, we can actually take note of shape much more readily. So here's a couple of shapes you'll want to note. So there's a common shape that may emerge depending on the phenomena, which is symmetrical. So you can see this histogram, obviously it's not perfectly symmetrical, but if I were to sort of draw an idealized continuous curve above that, we can see that that is a pretty symmetrical mound of data. So if in describing a histogram like that, I would definitely use the word symmetrical. The middle one, we see that we have a big bar, the peak at the left, and then it sort of tapers off to the right. And so this, again, if I were to draw my idealized curve, that would be something that I would describe as skewed right. Now, there's some confusion about why you'd say skewed right, even though the mound is to the left, but what you want to kind of imagine is that a value that over here to the right that's less common than a value over to the left is sort of the thing doing the skewing. It's pulling your attention away from the general trend of the data, which seems to be to the left. So it's being skewed to the right by sort of outlier type data. And similarly, this would be described as left skewed. Okay, so those are terms you're going to want to adopt when you're describing quantitative data. You're also going to want to talk about what's called the modes. So the humps in a histogram are something you'd want to mention in terms of how many there are and or if there are any. So for instance, on the left here, we see a very symmetrical histogram, and I'd say it's unimodal, meaning it's got basically one main peak. Okay, now we're going to learn that mode is the numerical value that occurs the most, but when you're describing a picture, we use the word mode to sort of indicate a hump or a peak. So both of these on the left are indications of unimodal, uni meaning one. The one on the bottom here happens to be skewed right, but it really does have one main peak here. So I'll just kind of indicate where the hump is there and here. Compare that to the middle one, in which we see here, which is the top one is somewhat symmetrical. Somewhat symmetrical or symmetric, but it's got two. It's pretty symmetric, but I've got really two humps here, one here and one here. So I would call that bimodal. Okay, and we'll learn that bimodal data sometimes indicates that you're really looking at a set of data that probably should be separated and looked at in terms of two groups. So the right hump might just when you're looking at a data set involving both men and women, this difference, these two modes might emerge as a result of actual differences between men and women. So a bimodal data set might suggest that actually there are two different groups within this data set that should be analyzed separately. Here's another example of a type of bimodal data set. We've got two modes that are two peaks here that are sort of split. So in the vocabulary word you want to use for a distribution that looks like that is bimodal. Sometimes data sets don't seem to have any peaks at all. This one here on the right is what we would describe as somewhat uniform. Now, a perfectly uniform data set looks like this. So that would be perfectly uniform. But of course, most of our data is not going to come from is not going to be idealized. So in any case, I would describe this data set as uniform, basically, because there doesn't seem to be any prominent peaks or humps that emerge once I've displayed the data into a histogram. So we've talked about shape using words symmetric, skewed right, or skewed left. We've discovered that distributions can have different numbers of modes, or of humps rather, and we use the terms unimodal, bimodal, and uniform depending on the situation. One important feature of the data we're going to want to mention or calculate if we have to is the center of the data. Now there are two main ways to describe the center of the data, the mean and the median, and these are our first look at actual statistics that we're going to calculate to describe the data. So, the center of the data really should give us a sense of what the typical value is. And I'm going to show you how to do this on the calculator. I'll do that in another video as well. I'll do it here just so you're aware that you really don't want to find the mean here by punching all these into a calculator and dividing by 24. That's too cumbersome. So I will show you how to do that on the calculator here. But in any case, notice I've already listed them from least to greatest. That'll be mainly for when we compute the median. But again, just to note, the mean and the median are measures of center, and depending on the shape of the distribution, it'll be more important to report one over the other in order to get a sense of what's a good representative for the typical value. But first, let's compute the mean. So we all understand that the mean is just, the sum of all these data scores divided by however many there are, 24. But just for now, let me show you how you can use your TI 83 or 84 to do this quickly rather than having to punch in all the buttons. So the first thing you're going to want to do is take out your calculator, hit Stat, and then Edit. And hopefully you have a list here. Maybe by default you have list 1. You'll want to hit Clear if there is any data already in there, just so that it becomes a blank list. And then all you do is just go down to the first entry and put in your first number, 45, press Enter, and then it'll record that and go down to the next entry. So you'll hit 61, and then 61 again, 64, etc. So I'll pause the video, let you do that rather than doing it all in front of you, and then we'll meet up after that. Okay, you should be now looking at a list that has all the data values. One way you can sort of check, in addition to going number by number, is you'll notice it keeps count of how many data values there are. So when I go down to that 100, it says, in my case, list 1, 24. And that, again, is telling you how many values there are. So that's a good indication that you didn't miss one or put in an extra. So now what you're going to want to do is hit second mode, which gets you back to the blank screen. You're going to hit Stat, go over to the column that says Calc, and then hit 1 for one variable statistics. Now at this point, if you put your data into list 1, then you can just press Enter, because by default the calculator will record what's in list 1. But just in case, what you should really do in general, if your data is not in list 1 but something else, like list 2 or whatever, hit second and then go find under the numbers whatever list corresponds to where you put the data. So I put mine in list 1, I'm just going to hit second 1. So it's going to compute all these statistics for the data in list 1. I press Enter. Now there's a lot here. For now, all we care about is the X with the bar over it. That is what we use to indicate the mean of a data set. Okay, so that in our case is 77.25. So that's the average test score. Okay, now the other thing while we're here, if you scroll down, you'll see a few other labels, and the number that says MED, which is the median, is 77. So the calculator can compute that as well. But let me just show you how you would do it by hand, just in case you're in a situation in which you might have to. So this the median, of course, means the middle number. Okay, and it doesn't involve adding or adding up and dividing by any number. It just involves putting them in a list from least to greatest and finding the middle number. So there's two cases you could be in. If there's an odd number of data values, then there will be a middle one. So if there's odd number of data values, then the median equals the middle number. Okay, so you can't divide the data evenly in half, but you can sort of pick that middle number and separate them into two halves after that. If there's an even number, as is the case for us, we have 24 data values. Then the median is just the average of the two middle numbers. So in our case, if we count in 12 on each side, that will leave no middle number. 12. So this right here cuts the data in half. So the median is right in between there. And when I say right in between, I mean the average. So if we just do 76 plus 78 and divide by 2, we get our 77 here. So that's how you'd calculate the median in either of those two cases. Now it's important, again, going forward, we're going to want to be aware of when it's relevant or more appropriate to mention the median as the center of the data, and when it's more appropriate to mention the mean. But at least here you can understand how to compute both of them.